Hello everyone, welcome back to my YouTube channel. In today's video, we are diving into a super important networking concept, router on a stick. So I will show you exactly what it is, why it is used, and how you can set it up to route between the multiple VLANs just using a single router interface. Okay, so you might be wondering what is the router on a stick method. So you can see there I have taken one single router and I will be using a single interface gig 000. So this method suggests that it is a network configuration where a single physical router interface is used to route the traffic between the multiple VLANs on a switch. So you can see I have taken the two VLANs here, VLAN 10 and VLAN 20 for two departments, HR and IT respectively. And using a single router interface, okay, I will be carrying the information of a different VLANs. Okay. I will route the traffic between the multiple VLANs on a switch. And it is also commonly known as, it is commonly used in inter-VLAN routing scenarios also. So let's dive into it. So you can see this topology, VLAN 10 and VLAN 20, HR and IT departments. I have taken the two L2 switches and one router. So let's do the configuration here. So first of all, I will configure switch 1 here. On a switch 1, I will create the two VLANs here as per the topology. You can see. First of all, I will mention, okay, enable, then configure a terminal. Then I will creating the two VLANs. First VLAN is VLAN 10. And for a VLAN 10, I will be giving the name as a HR. Okay. So name as a HR. And for a second VLAN 20, I will be giving the name as a IT. So for a VLAN 20, I will name as a IT. Then you can see the two interfaces FS01 and FS02. I will add these interfaces inside the VLAN 10 and 20 respectively. So FS01 is for VLAN 10 and FS02 is for VLAN 20. So I will add FS01 inside the VLAN 10. So I will use the command switch port access VLAN 10. Similarly, I will add the second interface FS02 in a VLAN 20. So interface FS02 switch port access VLAN 20. Okay. Also, apart from that, you can see there are two more interfaces FS03 and FS04. So FS03 is connected to our second switch, and this port is used as a trunk to carry the multiple VLANs information, okay, to communicate, not to communicate, but we can say carry the multiple information of a different VLANs. And FA04, it is connected to our router, single router, to connect the different networks here. So I will add these interfaces also. First of all, FA03, this is a switch. This is used for a trunk as a trunk interface for a switch. So I will be using a command switch port mode trunk. And for a router FS04, I will mention switch port mode trunk. Okay. So this is the configuration of a switch one. Same configuration we will do here for a second switch also. So I will just copy the configuration. I'll mention switch 2. And here also I will be creating the two VLAN 10 and VLAN 20 for HR and IT department. And the interfaces also I will be adding interface FS01 in the VLAN 10 and interface FS02 is for VLAN 20 and FS03, the third interface we will be using as a trunk interface because it is connected to our first switch, okay, to carry the multiple VLANs information FA04 we are not using because it is not connected here to our second switch. Okay. So this is our configuration of switches. So I will just copy the configuration here and I will paste inside the switches. So first of all, I will copy the first configuration and I will go to the switch CLI option and I will just paste our configuration here. Exit, exit. And if we want to see our VLANs, just type the command show VLAN brief. So here you can see two VLANs which we have created and the interfaces also got added inside the VLANs. VLAN 10 for HR department and VLAN 20 is for IT. And FA01 also got added into the VLAN 10 and FA02 also added into the VLAN 20 for IT department. Okay. Similarly, we will copy the configuration for a VLAN 10 and 20 and I will be pasting inside the second switch. I will go to the CLI option. I will just paste our configuration. Exit, exit. And here also you can see show VLAN brief. Our two VLANs 10 and 20 and two interfaces FA01 and FA02 also get added respectively inside each VLANs. Okay. After creating the two VLANs, now let's give the IP addresses to our end devices. So for VLAN 10, suppose for the this network, I will be using Class C network. So for this device, I will be using Class C IP address 192.168.1.1 and for this HR, this is also of VLAN 10. So this is, will be I will be using 1.2 here. And for VLAN 20, both the devices, I will be using different IP 192.168.2.1. This is of same class C, but it is of different network. So I will be here mentioning 2.2 here. Okay. And also I will be adding this IP inside the default. Okay. Inside the PCs also. So just click on PC, go to the desktop option, IP configuration, just paste the IP and subnet mask is as it is a class C IP address. So subnet mask is 255.255.255.0. Okay. Similarly for this laptop also go to the desktop section, IP configuration and paste the IP for this laptop. The IP is 1.2 and class C subnet mask. Okay. Default gateway also we will be assigning. Okay. I will show you later on. Click on the laptop, desktop, IP configuration. The IP will be 2.1 and subnet mask same class C. And for this, it is 2.2. So click on laptop, desktop, IP configuration and give the IP as a 2.2 and subnet mask is a class C. Now we will configure, if you try to ping the VLANs, okay, VLAN 10, let's try to ping 1.1 and 1.2. Let's check if we are able to ping it or not. Ping 192.168.1.2. So you can see reply is coming. Okay, as these are in the same network, so gateway IP is not required. Okay, so the information is carrying across from this PC to our first switch, then it is passing through our second switch, and then it's coming back to our second laptop. Okay, of this second switch. So if we try to ping the laptop, we will not able to ping because this is of a different network. So for that, we have to configure the router also. So let's try to configure a router here and then we will check the connectivity. So on a router, okay, R3 here this is or just mention R on router. And here you can see I will be using single interface gig 000, but You can see there are two departments, HR and IT, and two VLANs are created, VLAN 10 and VLAN 20. So we will be creating two default gateways here for carrying the different VLANs information. Okay. So I will creating the two sub interfaces here of a same single interface. So I will be creating the 000.1, and I will be creating the default gateway for a VLAN 10, which is 192.168.1.100 for a VLAN 10. And for a VLAN 20, I will be creating another sub interface, gig 0/0/0.2. Okay. And for this VLAN 20, I will be creating another default gateway, which is 192.168.2.100. Okay. So two gateways I will be giving for each VLAN. So for a first sub interface, I will be creating interface gig 000.1, and I will give one command encapsulation dot one cube, and this is for VLAN 10. So I will be mentioning 10 here. Then I will give the IP address as a default gateway IP for this interface is 192.168.1.100, and subnet mask is a class C, so 255.255.255.0 to exit. Okay, and then second interface sub interface is gig 0/0/0.2, and here I will be mentioning encapsulation dot one q for VLAN 20, and the default gateway for VLAN 20 will be 2.100. So just mention IP address 192.168.2.100, and default gateway, sorry, subnet mask is 255.255.255.0. Okay, exit. And then just our main interface is interface gig 0/0/0. I will giving no shut command to of the interface. Okay, so just copy our configuration, go to router, go to the CLI option, type no. Okay, we are into, we have to go into the privilege mode. So go to the type enable, then go to the configuration terminal mode. Okay, so right now we are into the privilege mode. So just paste our configuration here, and after this, if you want to see our interfaces, show IP interface grid. So you can see our two interfaces which we have created, sub interfaces gigabit ethernet 000, okay, dot one and dot two, and the interfaces sub gateway IP 1.100 and 2.100 we have given, and all are in the upstate. Okay, now let's try to ping 2.1 and 2.2 also. So ping 192.168.2.1. Let's check if we are able to ping it or not. First packet is request timeout is coming. Second is also request timeout is coming. So you can say we are not able to ping. Do you know why we are not able to ping? The reason behind is that we have created the default gateways for to our two sub interfaces, but we have not given these default gateways IPs to our end devices. Means if we click on the device, go to the IP configuration, We have given the IPs, but we have not given the default gateways here. That's why we are not able to connect the different networks. So just give the IP address for this VLAN 10. I will be giving as a 1.100. And for this device of VLAN 10 also I will be giving the same IP 1.100. Default gateway is 1.100. And for a second VLAN 20 devices, the gateway IP is 2.100. So just click on the laptop, go to the IP configuration and just paste the IPs 2.100 for both the devices. Go to the IP and just paste the IP 2.100, 192.168.2.100. Okay, and let's try to ping again. Go to the command prompt and let's try to ping 2.1 again. And let's see if we able to ping it or not. This time we should able to ping. First packet is usually initializing the ARP request. So you can see reply is coming. We are able to ping to different VLAN also. Let's try to ping this device, this laptop 2.2 also. 2.2. Wait for a moment. So you can see after getting first packet drop, the reply is coming from the other packets. So in this way, we can confirm that the different VLANs we can able to communicate, okay, using a single router. If you want to see through simulation mode how it is working, so I will show you. Just go to the simulation mode here, and just I will ping the this VLAN 10 1.1 to 2.2 again, and I will show you via simulation mode how it is working exactly. So I will ping again 2.2. Okay, so pinging is start. So you can see here first packet is generated. Then after clicking, first of all, this packet initially goes to our first switch. Then this packet is goes to our single router. Okay. After that, this packet is coming again back to our first switch. Then it is going to our second switch. And after going to this second switch, this going to our intended VLAN 20's device, which is 1 2.2. Okay. After going back to the destination, it is coming back again to our second switch, and after then it is coming back to our first switch. Then it is going again back to our router, not directly over to our device. It is going first again to our router, router again giving back to our switch. Okay, and then this switch will give this packet to our first switch. So in this way, simulation is happening. The packet is okay transferring across the network. So in this way, you can confirm that this is how router on a stick method works. Using a single router interface. We can carry or we can route the traffic between the multiple VLANs on a switch. Okay, so this is we can also commonly use in inter-VLAN routing scenarios. So this is the advantage that we can use is in the centralized routing, and also it works well in a small networks with a limited devices also. But one limitation is that as we are using the two sub interfaces, okay, for us for using a main single link, but it can become a bottleneck also in a large networks, because if this single link, if it is goes down, then whole network can goes down. Okay, it will be create a problem for whole network also. So it is not as scalable as a layer 3 switch also doing the inter-VLAN routing directly. Okay, so this is all about router on a stick method, and I hope you understand this video. If you like this video, please hit like button, and please do subscribe to my channel. Thanks for watching.